Hi everyone. In this video, let us understand the security design criteria for Amazon EKS. Security is one of the most important design criteria for all the obvious reasons. We always say security is always job zero. Security is important for any workload, but far more important for containers, given the nature of the containers, how they are designed. For example, in the world of virtual machines, which is based on operating system virtualization, every application runs in a dedicated operating system. It provides better security and isolation. But VMs brings their own complexity in terms of startup times and managing at scale. In containers, which are based on kernel virtualization technology, security is much more important because every container and all the applications will be leveraging the same kernel. In a platform like Kubernetes, security is more complex and needs to be addressed at many dimensions. Now let's get started. Let us say we have deployed an Amazon EKS cluster in the cloud. So where do we start? First, let us understand from security and compliance team persona. First, we need to create IAM roles and users with the required permissions. It could be IAM users or IAM roles. These roles and users should be given only required permissions to access the resources. Now, in the world of Kubernetes, we have the similar permissions in terms of the roles and the role bindings. So, the team which manages the cluster security needs to create the right roles with the right permissions in IAM, in AWS Cloud, and also in the Kubernetes. Let us say we call this authentication authorization. Authentication is getting access to the Kubernetes control plane API server. And authorization is what we can do inside the cluster. Think of like this. A passport is similar to what authentication. It means a person is citizen of a particular country. But a visa, which provides you what he can do, where he can go, more like an authorization. Just to draw some parallels. Now, what next? So, the team which manages security also might need to create system OS AMIs because certain organizations, mostly in the FSI segment, needs to comply the operating systems for certain benchmarks. So they need to take a base operating system AMI and harden it for various specifications. For example, CIS benchmark. So let us call this infra security. It's a second dimension. Next, there is a platform or a DevOps team which will be using the roles, the IAM roles created by the security and compliance team, and they will be deploying the cluster. They will do CRUD operations, create, read, update, and delete operations on the cluster. So the DevOps team creates the cluster when the developers come into picture. For example, to deploy the applications, we need to build the container images and push them to ECR. Both the ECR and the inspector services provides the capability to scan the container images. So scanning is extremely important before we deploy the application into the cluster. So this is what we call as image security, the third dimension. So developers will take this image, create the manifest files and deploy into the cluster. And to deploy into the cluster, developers needs to access to the cluster. So that is where we will be using some of the roles which are created earlier by the platform and by the security and the compliance team. And these roles are authorized to access only specific namespaces which the developers are working on. So the isolation is provided at a namespace level for a given role for each two. Okay. Now, what next? Developers deploys the pods and the containers will be running. And during the deployment, they need to ensure that the pods are not given extra privileges than what is required to do their job. For example, pod should not run as a root user. they cannot access the system calls unnecessarily on the host kernel. Things like that. So all of that is controlled through something called pod security standards. Earlier, there was pod security policies, PSPs. They were deprecated, now replaced by something called pod security standards and pod security admission controller. So this is what we call pod security. And apart from that, there is something called runtime security. During the runtime, the container should not access extra system calls or unnecessary kernel files in the file system, or they should not access the host file system. So all of that is comes under runtime security. Now, there is something called network security. There is a use case where certain applications should not access other applications. They should be isolated at the namespace level for network access. So the Kubernetes network policies provides this capability to isolate the access to a specific pod, specific namespace, specific port, things like that. So say the application is deployed in the EKS cluster. Applications may need to access AWS resources. For example, it could be S3 service, DynamoDB, or any other AWS service. To access any AWS service, you require IAM permissions. We cannot hardcode the IAM permissions inside the applications running in the cluster. There are some better ways to do that. One of them is IRSA, which is IAM role for service account. Other option is EKS pod identity, which is recently launched feature which also allows very granular permission to the pod. Both the IRSA and EKS pod entity can be used to provide access to the pods running in the cluster to access any specific AWS resource and service. And then comes the last one. The SRE team, which monitors the health of the cluster, needs to monitor the audit, logging, and the monitoring. So they may use services like GuardDuty, which is integrated with EKS for audit log monitoring or runtime protection. So this is a sixth dimension. Just to summarize, the security and the compliance team first will create the IAM roles to create the clusters and also for the developers to access the cluster. The platform and the DevOps team will use these IAM roles and to create the cluster and the resources. And then developers will use their own respective roles to access their namespaces. And during that process, they will ensure that the containers are properly scanned, there are no vulnerabilities, and also the pods are properly configured not to access the host level kernel unless they are required. Then they also configure the network security using the network security policies. And the application developers also needs to implement the application security in terms of storing the credentials in the secrets using techniques like IRSA and pod identity. And there is one more technique called envelope encryption that we will discuss in detail. So the last one is audit, logging, and monitoring, which typically falls into the SRE team so that they will continuously monitor for any anomalous activities in the cluster. So let us summarize. First, we need to choose the right authentication authorization controls. EKS provides different options. We can use IAM, OIDC, and service accounts to access the cluster. Then we need to choose the right hardening for the operating system because certain organizations require security and complaints, especially in the FSI segment. So we need to ensure that the OS is hardened on a regular basis. Then we need to take care of the image security, the pod security, the runtime security, and implement the network security between the applications running in the same cluster, leverage the Kubernetes native network policies. And then the application developers needs to maintain the secrets and the credentials securely using some techniques like we discussed earlier. Now, the control plane audit logging is also important because at the runtime, if some hacking happens or if some applications are exposing their secrets or if they're running some extra system calls, all of that has to be monitored through the audit logs, runtime protection. This is not an exhaustive list. There are much more than what we discussed. I just mentioned some of the top areas that we need to keep in mind while designing the security on EKS clusters.